Alright, welcome back to Mr. PL's with Algebra. This is Unit 4, Topic 3, Lesson number 5, Perfecting My Quadratics, or Perfecting My Quads, the name of it. And we're going to start off with a warm-up with substitution methods. So this takes us back to function notation. It's been a while since we've seen this. A of 3 set in function notation. That means we're substituting 3 in for x and solving. 3 here, 3 times 10 minus 3. In that case, 10 minus 3 is 7. 3 times 7 is 21. This time we're doing A of 4. 4 being x, substitute it in. Just like you do for quadratic formula, you're going to substitute it in. Substitute in for x, and then solve, and you get 24. Now, notice that question C is a little bit different than A and B in the fact that this time we're saying that the answer of x equals 0. So we're trying to find, well, what answer would equal 0? Kind of like, once again, we do in like zero product property. So we're going to set equal to 0 with x. We're going to substitute x in for x. So I know that doesn't really make any sense. But now we can take each factor and solve it using zero product property. If x is one of the factors, then x is equal to 0. Because if x is 0, it doesn't matter what this ends up being. It would have been 10, and 0 times 10 is still 0, so that's an answer. And then we can set the other factor to 0, and then that gives us an answer of 10. So the answer is two different answers, 0 and 10 are the two solutions. I'm going to do the same thing over here. I'm going to put 10 in for x and solve. So that would be 10 times 50 minus 10. Okay, pen. There we go. Subtraction. Whatever. 50 minus 10 is going to give us 40. So we can say A of 10 is equal to 10 times 40. And then A of 10 is equal to 400. All right, A of 20. So we put 20 in for x, so that's 20 times 50 minus 20. And 50 minus 20 is going to give us 30, and 20 times 30 is 600. So A of 20, pen's not working out so well there, is equal to 600. So what is the answer equal to 0? So we can say x equals 0 because that's one factor right there. And we could also solve it the other one, so 50 minus x equals 0. I can just simply add x to both sides, and that tells me that x must equal 50. There's your two answers, 0 and 50. All right, zero product property is one of the ways that we solve. So that one I had a little bit of a couple of different ways we solve. So there's 5 different ways. Now, I think table and a graph are really the same method because you're really just seeing the same information. Zero product property we did in, I believe, the first lesson. Completing the square we have done as well, and quadratic formula. So these are all the ways that you can solve a, I'm sorry, I almost said a system. These are all the ways that you can solve a quadratic equation. Now, the two new ones happen to be those tables. So table is going to be what Carlos likes to do, and Clarita likes to use the quadratic formula. So we're going to use all those methods. Now, I'm going to talk about this at the very end because really the point of this lesson is for you to use all the different methods and get the answers, I should say, and then determine, well, what would the problem look like when that method is the best or the easiest? Carlos' strategy was to make a table, x and y. Now, what you would want to do is you'd want to put this into the graphing calculator, plug it in, and then just read the numbers off of the graphing calculator. So, if my memory can serve me right, I believe -30 was the answer here. And then if I was just going to go down and keep 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I believe 1, 0. Oh, sorry. So here we go. So 0. This was a 0, and this was also a 0. I'm going off of memory here. -2 in for x. That would be 4. 4 plus 4 would be 8. 8 minus 15 would be -7. So that means this was -7. I believe this one, next one was -12. And then the next one was -15. And then the last one in the middle, -16 was the vertex. All right, so there's simply the table. We got two different solutions right there and right there. Clarita's strategy is to use the quadratic formula. So A is 1, B is -2, and C is -15. So we're going to plug those numbers in. So the opposite of B, negative B, it would be 2 plus or minus square root of B squared, that's -2 squared, minus 4 times A, which is 1, times C, which is -15. 15 divided by 2 times a, which is 1. All right, so now we're ready to solve for that discriminant. 2 plus or minus. Negative 2 squared is 4. Negative 4 times 1 is negative 4, and negative 4 times negative 15 is positive 60. Now, that gives us a discriminant of 64, which is a great discriminant because that's a perfect square. The square root of 64 is 8. So we now got 2 plus or minus 8 divided by 2. So now we're ready to solve it twice. We're going to do 2 plus 8 over 2 and 2 minus 8 over 2 to solve for our two solutions. 8 plus 2 makes 10. 10 divided by 2 is 5. There's one answer. 2 minus 8 is negative 6 divided by 3 is, 2 minus 8 is negative 6 divided by 2 is negative 3. Now, what you're probably noticing is that both the table strategy and the quadratic formula, we got the same answers. Now, we should get the same answers no matter how we solve it. We're going to next do the square root method. So we start off with this. T strategy is to make it a perfect square. B squared, so if I have negative 2 longs on this side of the square, negative 2 over here, that means I need 4 units in order to complete the square. But in this case, we have negative 15 units, which means I need to add a lot of units in order to complete that square. Let me just make, so showing you a diagram. So we've got one flat, we've got 2 longs. Okay, so it's not 2 on each side, so it's 1 unit on each side, 1 long on each side, or 1 X tile, which means we need 1 unit tile right there. But we're negative 15, which means we have to add 16 to both sides. X squared minus 2x minus 15 equals 0. So let me tell you what I'm talking about. So if I need 1 unit to make this a perfect square, but I've already have negative 15, I need to add 16 to complete that square. So that's going to be x squared minus 2x plus 1 equals 16. Now that's perfect because this is now a perfect square of x minus 1. Now if you don't remember, that's negative 1 plus itself and negative 1 times itself. That's how you know it's a perfect square. Equals 16. Now that's also a perfect square. So this is a perfect question for this method. And the square root of anything squared is itself. So we get x minus 1 equals both positive and negative 4, square root of 16. And we're ready to solve it twice. Now I'm going to solve it over here. Run out of room. X minus 1 equals 4. And x minus 1 equals negative 4. Add 1 to both sides means x is 5 on this side. And add 1 over here, you get x is negative 3. Same answers as we had on the 2 previous methods. Now, Tahani strategy is zero product property. It's already set equal to 0. This is actually my preferred strategy for this question because I think it's going to be the least amount of work. What two numbers give me negative 15 but also add up to negative 2? So that would be negative 5 and positive 3. So that's x minus 5 times x plus 3 equals 0. All I did so far was change standard form into factored form. Now, since I've got it set equal to 0, anything that makes either one of the parentheses equals 0 is a solution because anything times 0 is 0. Zero product property. So this answer is going to be 5 and this answer is going to be negative 3. Now, like I said, I solved that pretty quickly because this is probably my preferred strategy for this because this is very easily factorable. And I'll probably mention that again when I get to the next page. Zach's strategy is to make a graph. And I'm just going to make a rough graph here. You can put this in a graphing calculator and sketch it. But you're going to notice it's going to look something like this. And when you look at that graph, you're going to notice that right here it's going to hit the x-axis at 5. So that's one of the solutions. And here it's going to hit at negative 3. So there's the other solution. And that strategy works perfect for this as well. So this is going to be a good strategy because both the answers are integers. But this strategy, as I'm going to mention here in just a moment from now, is that the graphs are not very good when the answers aren't integers. So when you get decimal answers, it's not very good for that because it's very hard to tell what the answer is just from looking at the graph. All right, now I'm going to skip through a couple of these questions. Now, like I said, this lesson was designed for you to do these other problems, and you'll notice that some strategies don't work out as well as other strategies. So the point of doing the lesson with, questions with leading coefficients and questions that aren't necessarily factorable is that you see that some strategies will work better than others, depending. Square root method might be the best method, it might be factored form. So we're going to talk about that now. So Carlos liked to make a table. So when is that the best strategy? That only is a good strategy when the answers are integers. Answers must be integers. Because if it's not an integer, then you're going to look at that table and you're not going to see the answer. And then if you really know how to use the calculator pretty well, you know how to set the table to make it whatever you go by any increment that you want. That's, I believe, the second tab on the top. You just press second and then the second tab, second and then trace, I believe. And then you can set up the table, and then you can make it go by any increment that you want. You can make it go by 0.1s if you want to. And then that might be able to get the answer that way, but that's probably not a good strategy because that's going to be a lot of work, and then you're going to end up doing another strategy anyway. Table and graphs are the exact same strategy, and as I had mentioned before. So I'm going to say those basically are used for the same reasons. If the answer ends up being an integer, then that's going to end up being a good strategy. Now you might be wondering, well, how do I know if the answer is going to be an integer? You don't. So when you look at a question, you're going to have no way of knowing that if that's going to be a good strategy or not. But if you do it and it does work out, then you might have just saved quite a bit of time. So maybe these are strategies you want to do anyway first, because they don't take a whole lot of time, and if they do work out, great. If they don't, then you can use one of the other three methods. Now, let's go to zero product property. That's probably my favorite strategy to do personally, because I think that is the easiest strategy, but it only works if the quadratic equation is factorable. So it has to be factorable for this strategy to work. And I know if there's a term is a leading coefficient, if that term is not 1, it might be a little bit tougher to factor it. So anytime you have an a term that's not 1, I probably would skip this method and go to something else. Me personally, I would then go to quadratic formula. Now, completing the square, and by the way, this is best, Tahani's method, which is zero product property, is perfect when they give you factored form. If you have factored form and it's already set equal to 0, then boom, this strategy is going to be very, very simple. Whereas completing the square is probably best when you're given vertex form. And the reason being is because if you have vertex form, it's already in parentheses. You already have a perfect square on the left-hand side. All you have to do is move your k term to the other side. So perfect for that, because most quadratics are not perfect squares. And if it's not a perfect square, you're going to be dealing with weird decimals. I would not want to do this strategy. Even though technically this strategy can be done pretty much every single time. You can always use this strategy. I know I probably didn't push it as much in class because it gets pretty difficult when you don't have perfect squares. Quadratic formula is my go-to no matter what. It's my last resort. It always works. It's never not going to work. So basically, if none of the other strategies are going to work, then quadratic formula is where you want to go. The negative b plus or minus square root of b squared minus 4ac divided by 2a. That's a mouthful. Yes, can it be a lot of work? Absolutely. But it's always going to work. That's what's nice about it. All right, getting to the homework. So using any method, we're going to use any method to solve these 1, 2, 3, 4, 5, 6 questions. I'm noticing I only have 2 minutes to do this. I'm going to do this pretty fast. 60. I'm asking myself, is this factorable? Well, 20 times 3, it looks like it is. No, that would be 23. That is not going to work. 15 goes into 60. Let's see, twice into 30, so 4 times. 15, what did I say? 15 and 4 makes 19, not 17. That's not going to work either. It looks like if it is factorable, I am not seeing it right away. So I might want to go straight to quadratic formula in this case. A is 1, B is 17, and C is 60. Let me pick one that is factorable. Negative 5, nope, that's not factorable either. 39 can be divided by 13. 13 and 3. Okay, so that's x plus 13 and x plus 3 equals 0. Now set each one equal to 0 and solve. X plus 3 equals 0. So the answer here is going to be negative 13 and negative 3. All right, this one, if I move the 8 to the other side, so that's going to be 8 and 1, no, 4 and 2, no. Looks like that one's not going to be factorable either. Plus 8 equals 0. This one, if I go x squared plus 6x minus 7 equals 0. So that looks like that is factorable. That's going to be a perfect, that's going to be a rectangle of x minus, no, let's say plus 7 times x minus 1 equals 0. So it looks like our answer is going to be -7 and +1. Yeah, I'm skipping steps here because I notice I'm running out of time. So what I might have to do is just do another video of this because I only got about 5 seconds left.